Well, thank you, Jeff. Can everybody hear me all right? Actually, I have good news, Jeff. I hear that Short and Bald is coming back. So, you know, Jeff called me up and he said, would you come back to Indiana and give us a talk? And I said, okay. He said, but we want you to talk about corridors. He said, can you do that? And I said, I guess so, but that'll be a new talk. He said, that's all right. I said, but Jeff, you know, talks are like wine. They get better with age. So if I give you a new talk, it will be young. He said, that's okay. So I'm giving you a 2011 vintage talk on networks for life, and it will be the first for all of us here. So let's see how it goes. Let's return to Joe. Joe is the eastern box turtle, and it's true. Joe was common at one point. And most people think that Joe lives in old fields. That's where you typically encounter Joe. But actually, Joe spends most of his time, so this is where you normally would find Joe. Joe spends most of his time in the woods, and he spends most of his time hiding under vegetation in the woods. In the spring, Joe does go a courting, and this particular Joe was successful. He had his neck out. It was a beautiful shot until he moved one branch to get the shot, and then he hid in there. But Joe scored on this one. And that resulted in new baby turtles. But this is Joe also he does his courting in the woods as well. But this is where it changes. Mrs. Joe seeks a sunny place to lay her eggs. So she will leave the woods. She will seek a little sunspot and typically leaves a small woodlot in order to lay her eggs. Now the baby turtles hatch, and of course they hatch where they were laid, which means they're outside the woodlot as well. We know very little about baby box turtles because they spend the first few years actually underground. We discovered this guy in our front yard. We went to plant a tree. We actually digging up, and out came the turtle. But the next time you actually start to see these turtles is when they're back in the woodlot and they're a couple years old. Now, this is the University of Delaware. We call it the Ecology Woods, or just the UD woodlot. It's 35 acres. And in 1968, a man by the name of Dale Bray decided he would collect and mark every box turtle he could find in this 35-acre woods. He did that, and he found 96 of them, I believe, marked them all. So this is what it looks like from the air. You can see that you know, it is a nice little habitat patch, but it's completely isolated, and it has been isolated for at least 100 years as far as we can determine. It used to be isolated entirely by farmland. Now it's isolated by farmland on two sides, athletic fields on one side, and a serious road called Route 4 on the south. If you zoom back even further, I discovered Google Maps for this talk, and it was lots of fun. But this is the next closest woodlot that has any box turtles, and then again over here. We're talking about more than 1,000 yards away with, again, very serious impediments to box turtle movement. So the box turtles in this woodlot are completely isolated from the box turtles in this woodlot and the box turtles in that woodlot. And that is the problem. Even to go outside of the woodlot to lay your eggs, if you're Mrs. Joe, becomes a very dangerous event. If she leaves on the side of the agricultural fields, she does it in the early summer. She often is plowed under, or she's simply mowed. If she goes south, she gets a very unhappy event on Route 4. And that is why when the box turtles were resurveyed, come back here, in 2002, there were only 22 of them. And an informal survey that didn't involve radio tracking last year showed only 12 turtles. So there's little doubt that the box turtle population in the UD woodlot is not sustainable. It is declining. All the turtles we find are very old at this point because there's absolutely no recruitment into this particular population. Their fate, in fact, was doomed as soon as that woodlot was isolated 100 years ago. It took more than 100 years for that population to disappear. Hasn't yet, but we know it's going to. And that's what we call the extinction debt. So it takes a long time for the extinction debt to catch up, depending on how long-lived your species is. It's not just box turtles that, of course, have a problem with this. but all of our amphibians have the same problem. Our snakes have the same problem. Snakes, you know, they don't have big home ranges. When they leave their little protective areas, they get squashed on a road, or they simply find themselves in a place that they cannot exist. And of course, there's no genetic exchange of material between populations. That becomes really critical. It's also a problem for flightless carabid beetles. I mean, who would think that an insect couldn't make it in a 35-acre woodlot? But all of the flightless species of carabid beetles in our 35-acre woodlot have disappeared already. Their extinction debt is realized. And it's not because they're getting squashed or mowed. It's simply because that area is not large enough to sustain them. And that's why biodiversity is having so much trouble in this nation, because we've set aside these parks and preserves, and those parks and preserves are too small. Why are they too small? Well, a couple of reasons. Some of them are evolutionary reasons, some of them are ecological reasons. Let's just talk about the most obvious one, though. When you take a large habitat and you shrink it down to a small little habitat, I'm having a little trouble regulating this here. You take large populations and you shrink them down to tiny populations. Anything that's living in that little woodlot is just a tiny population compared to what it was when it was large. Now, all populations fluctuate. In good times they go up, bad times they go down. If you're a large population, even when you're in your down cycle, there are enough individuals to carry on. So that's all right. But when you're a tiny population and you fluctuate naturally, you typically hit zero. You blink out of your little habitat patch, and that's called local extinction. We have some very nice long-term data sets that have documented this, and people are looking at this all over the world. This is one of the nicest because it's old. It's about 100 years old. That's Barrow, Colorado Island. It was built, it was created when we built the Panama Canal in 1914, so it has been almost 100 years. This was a mountaintop. It is now surrounded by water because we dammed up the river that went through there, the Chagres River. The water rose and surrounded that and isolated that little piece of real estate from the rest of the Panamanian forest. When that happened in 1914, there were 283 bird species on Barrow, Colorado Island. So far, it has lost 65 species, which is 23% of the species that exist there. It continues to lose species over time. So when will the extinction debt be realized for the birds that are living on Barrow, Colorado Island? Nobody knows. We'll see. There always will be some birds, but how many are going to be able to survive there over the long term? Again, it's anybody's guess. What's interesting to me is that Barrow, Colorado Island is not so small. It's 3,700 acres. Compare that to the average woodlot size in Delaware. Average woodlot size in Delaware is 10 acres, 370 times smaller than BCI. So what do you think is happening in the populations in our little woodlots? This is you guys cannot hide from me now that I have Google Maps. These are little forest fragments somewhere in Indiana, just northeast of Indianapolis. So you definitely have the same problem. We have some nice designs here, but they are isolated. Let's look at larger habitat fragments. This is Ashdown Forest. This was the inspirational forest for A.A. Milne's Winnie the Pooh, the 100-acre woods. It's twice the size of Barrow, Colorado Island, almost 6,000 acres. So 600 times the size of the average Delaware woodlot. And it's not surrounded by water, it's surrounded by development in England. Has been since 1920. Since 1920, 47 plant species have disappeared. Again, who knows how many will disappear before the extinction debt is realized? We don't know. So we're talking about fragmentation of habitat. What has fragmentation of habitat done to biodiversity? These are some stats that I shared with you last time, but it's worth reviewing. We have 200,000 species of plants and animals in the U.S., and folks at the State Natural Heritage Centers all over the country are busy assessing their conservation status. Huge job. They don't publish on it very often, but the last time they did, they had found that they'd looked at 1/8 of the species. And out of the 1/8 of those species, they found 4,252 to be imperiled, on the brink of extinction. That's what imperiled means. It means they're now so few in numbers that they're no longer performing their roles in their ecosystems. You can still go out and you can find one here and there, but they are functionally extinct because they're not enough of them to perform those roles. Well, that's based on looking at 1/8 of those 200,000 species. If that same pattern holds when they look at all 200,000 species, that'll be about 33,000 species that are on the brink of extinction. Of course, they're not just going to hover on the brink of extinction. They're going to proceed right along to extinction. We know more about birds than any other group because we have more birders out there measuring what's happening to birds. One of the things birders do is a breeding bird survey. Every spring they go out and they count the number of breeding birds of each species in the entire U.S. And these are data for neotropical migrants, the birds that breed in North America and then move to Central and South America for the winter. This is the Mississippi flyway. That's your flyway. This is the Atlantic flyway, my flyway. You guys are doing better than I am, but neither of us are headed in the right direction. We do know that since 1966, when this survey started, common birds that used to be common, like the wood thrush, have lost almost 50% of their population. Golden winged warbler has lost 66% of its population. Cerulean warblers lost 84% of its population. I could do this all night because 127 species of neotropical migrants are in steep decline. So biodiversity is an essential, non-renewable natural resource. It's essential for all the reasons I told you last time I was here. It is biodiversity that runs our ecosystems. We cannot exist on this planet without other species to produce the ecosystem services that keep us happy and healthy. It's a non-renewable natural resource because when these species go extinct, they're not coming back. Not in any type of time frame that will help us. But we are fragmenting them to extinction. So, fragmentation is the problem. And corridors are the solution. This is not news. We've known this for quite a while. And that's because if you connect the isolated habitat patches that we have out there with viable biological corridors through which animals can move, and not just move, but live. Some of these corridors are going to be quite extensive. The animals have to be able to live and reproduce within them for them to be any good, unless you're talking about mountain lions or something. So if you connect these isolated habitat patches with biological corridors, they're no longer isolated. And if they're no longer isolated, the populations within them are no longer tiny. And if they're no longer tiny, they no longer are going to blink out in local extinction when they fluctuate through random processes. So biological corridors, theoretically, are the solution to the extinction crisis. All we have to do is connect all these habitat patches, and we can solve this problem. So that's great. Now, there's some convenient opportunities for building corridors that I'll talk about first. We can build them along mountain ridges where we shouldn't be doing anything else anyway. We can build them along riparian corridors, which has a number of wonderful benefits. Power lines, have you thought of power lines? And roads. 4 million miles of roads in the U.S. Great opportunity for corridors if that will work. Now this is the what's left of the Appalachian Mountains in parts of Pennsylvania. But Pennsylvania actually, at the turn of the century, Pennsylvania was doing a terrible job at conservation. They essentially had logged and burned the entire state. But since then, they decided that wasn't such a good idea. And they've allowed the forest to come back, particularly along those mountain ridges. They're mostly state game lands, but they create very effective, large, long-distance biological corridors. This is just part of the map. They go off, and then they actually follow down all the way down through West Virginia. So serious corridors here in the opportunity of mountain ranges. You don't have to have the Rockies. You don't have to have huge, lengthy mountain ranges in order to do this. This is essentially a hill. It's too steep to farm conveniently. It's too steep to build on conveniently. We're pretty good at building on hills, but it's not a great idea. And it also is a perfect place to conserve water for functional watersheds. So there's lots of reasons not to develop these mountain ridges. And if we don't do that, we have created very good habitat patches. This is Newark, Delaware. That's the field house of the University of Delaware, which is right here. And this is called Iron Hill. People don't think about Delaware in terms of its hills or its mountains, and that's because that's the only one. But look, it's an effective corridor right there, just south of the university. There actually are developments up there. There are homes up there. There's some parks. So it's not no man's land, but it still is functioning as a workable, functional corridor. Excuse me, I have a little cold here. Let's talk about riparian corridors. This is probably our best convenient opportunity because we already have a network of riparian systems, of streams and rivers, even first-order streams that snake their way out throughout the country. Almost everywhere we have an opportunity to create a riparian corridor. What you're looking at here is just a shot I took out of the plane, but there is a little stream or river, probably a pretty good stream, snaking its way all the way up to the horizon. This is an excellent opportunity for a corridor that has been realized. That's not always the case. Now here's another riparian corridor. This is in an area of Pennsylvania just southwest of where I live. We certainly have done a good job of taking everything in between the little streams, but those corridors still exist. We've left the vegetation on both sides of these streams, and they are functioning as very effective corridors. And you can see how complete the coverage can be if you simply have appropriate vegetation on both sides of an aquatic system. The benefits are obvious. They are intercepting, this is all farmland here, so they're intercepting the fertilizer that we put on. We have a terrible problem with fertilizer, not necessarily because farmers over-fertilize, but because it is very difficult to time a fertilization event in terms of the rainfall events. If the plants don't take up the nitrogen and the phosphorus after we put it on, and you have a huge rainstorm, which you guys aren't having these days, but we are having. We've had about 22 inches of rain in the last month and a half. It just washes right down. If we can intercept those nutrients before they get to the waterways, that's a good thing. So corridors are best when you have a lot of vegetation on both sides of the stream. So here's another shot. The more you can vegetate, the better. If your streams are barren now, don't give up. These plants grow, and you can reestablish these corridors pretty quickly. This is half as good. So here we have farmland. The streamway is right there. Well protected on this side, not protected at all on that side. I will take half as good over nothing, but still, there's an opportunity to expand the corridor on this side. But this is a lost opportunity. It's actually a disaster. This is a landfill right here. And this is the Christiana Creek as it enters the Delaware Bay, right near our university. And of course, there was, waterways used to be and still are important transportation avenues. I mean, that's where commerce happened. That's where we built our cities. That's where we threw all of our sewage. We weren't thinking about preserving biodiversity along these corridors, but we really should be. We really should be, particularly with projected sea level rise. Corridors, vegetated corridors, can help in that regard. Here's another lost opportunity, wonderful parking lot right next to the same creek. And here we have the agricultural end of the disaster of riparian corridors. This is a little farm, little beef cattle operation just down the road from me. And there you go. There's absolutely nothing there but grass. The cattle are trampling that stream every single day. We've known about this for a long time, and you'd think because we know about it and we say don't do that it would all be gone. But it is very difficult for me to find in southeast Pennsylvania a stream that doesn't look like that. So these are lost opportunities of corridors. These streams run right down into the Chesapeake Bay, and everybody wonders why the Chesapeake Bay is nearly dead at this point. So lost opportunity there. Here's another lost opportunity. Of course, we humans love waterways, and if we build a house up here, we want to be able to see the water. So we make sure we have grass right down to the water. It doesn't matter whether it's a river, it doesn't matter whether it's a Chesapeake Bay or just a lake. We do this almost everywhere. And there ought to be a law. This is the worst thing we can do. What's the solution? I know that a homeowner that buys near water wants to be able to see that water. So here's the house, and this could be the original or the landscape the way it looks now. That's all the erosion that's happening because we've taken away all the plants and, of course, all the nutrients that homeowner is putting on that lawn of going straight down to the water. Let's get a lot of vegetation into the area. We can still have traditional lawn up here with a little path, maybe another traditional lawn spot for our little gathering or wedding or something here. But this is a eastern meadow, and these are shrubs that block the flow of nutrients down to that water edge. We still have an open, complete view of the waterway. If you own on waterfront property, consider a design that has, some similarity to this. Okay, let's go to Indianapolis. Here's your river. What is this? The Whitewater River? Is that right? White River? Yeah. There it is, right through the town. Of course, rivers, streams, great opportunities for corridors. You cannot hide from me because I have Google Maps, and I can go in and see how you're doing. And in some places, you're doing really well. I understand the challenges of reclaiming property along a river, particularly property that's already been taken. But look at the flooding events that we repeatedly have in this country. When you flood out an area, that is a great time to say, we're not going to move back there. We're actually going to reclaim it. So we've got a pretty good corridor on this side. We're not going to throw out all these houses. Better corridor on this side, and it snakes around here. And all of these open spaces are pretty well vegetated. So that's good. I don't know if you can recognize where that is. I can't, but here's just a little bit upstream, though. And I just want to make sure, if there are any policymakers in here, that we're clear about what a functional corridor is. Because we hear the term open space all the time. And I see a lot of open space along here. But if you study it very carefully, you're talking about grass. Grass is not a functional corridor. It may be open space, maybe people can go throw the frisbee there, but that is not a functional biological corridor. So it's also a costly thing to maintain. There are lots of opportunities just in this single shot here. Look at all that along there, where we could take these open park-like systems and reclaim them, even if it's just some of them. Let's put some trees into these corridors. Roads as potential corridors. Roads are great because they go on forever. They go right up to heaven. Now, in this case, this is a road that's cut right through a forest. You wouldn't look at that roadway and say that's a functional corridor. It's actually a barrier to movement between these habitats. But lining, those 4 million miles of roads in the U.S., lining almost all of them are grass strips on either side. Sometimes it's extensive grass strips. And we also have median strips along many of those corridors. This is the Taconic Parkway in New York State. Anybody driven on that? It's a very pretty road. But look at the size of this median strip. It was built a long time ago. There's a grass strip on either side that they're mowing. But this median strip is the real opportunity I'm looking at here. What a lost opportunity we have here. The Taconic Parkway is funny, though. It's schizophrenic. If you go just a little farther down the road, this is that median strip, and there's a full-fledged forest in it. So in some places, they leveled the forest. In other places, they did not. In some places, it's a fully functional corridor. You don't even know there's another road on the other side because they have been so effective at creating a corridor right there in the grass strip. Here you've got grass strip which goes, and then the trees start. So I don't know what the historical event was that created that, but we can put those trees back. By the way, what do we put in our corridors? Generally speaking, you would put the habitat that used to be there back, because that will support most of the creatures that need to be there. There are some exceptions, and we'll talk about that in a second. There are also some downsides. Excuse me. There are a number of studies now, growing number of studies, some in Canada, some in the U.S., some in Europe, that are showing that these types of corridors along roadways are actually pretty effective. Animal populations are increasing, and they're serving as corridors where animals can move and actually breed and survive, depending on what the animal is. But there are downsides, and you're looking at it, of course. We don't want to create a situation, so supposing we put a giant milkweed bed along that center grass corridor there, or if you have a smaller corridor and you have a lot of milkweed, and you pull in your monarch butterflies and other milkweed insects to use that milkweed, are they going to get flattened by cars? I've watched monarchs. They're smart, but not all that smart. And they can easily fly over this car if they just give it a little thought, but often they do not. So we don't want to create a sink situation where we're drawing in animals with good habitat and then plastering them with our cars. So we have to think about that a little bit. But other opportunities associated with our roadways provide corridor options. This is I-95 going down the eastern corridor, and this is Route 896, goes to the University of Delaware over here. That's one of my study sites right there. This is simply an on-ramp onto 95 that, of course, has cut this patch of forest off from this one, but it left the forest. Right on the other side, the forest was cut down on either side. So these areas are mowed constantly. This picture was obviously taken in the middle of the summer when that grass is entirely brown and dead. It's supporting nothing, when it could have been this functional forest. We have these little adopt a highway groups that go out, and I guess they just clean up the highway. I'd love to see somebody adopt an entrance ramp and put the plants back that ought to be there. It relieves the mowing responsibilities, and you could actually create viable habitat again. And these areas are big enough. You're talking about acres there that animals could probably live there without being flattened all the time. This is a rest stop on the Pennsylvania Turnpike that I couldn't help but take a picture of. I don't know how many acres. You know, it goes off way down here. How many acres of grass are there? For what reason? I do not know. There's not a single, maybe it's for dog walking or something, but believe me, they must have big dogs there, because that is a lot of area that is mowed for no reason. Right on the other side of the little entrance ramp, they do have a few trees in. Put some trees in these other areas. If you counted up the number of these rest stops and entrance ramps and everything all over the country, if we have 4 million miles of roads, I mean, we're certainly talking about at least 1 million of them. So what a great opportunity to get a lot of plants back into the landscape. How about power lines? Most people don't think of power lines as a Carter option, but you know, they also go on forever. That's they could represent, excuse me, represent an excellent option for reforesting. But then you say, well, look, all they've really done is interrupt the forest. So this would be kind of a reverse Carter. In this particular case, this is New Jersey right here. But one of the habitats that has disappeared the most from this area of the east is bushy scrub. And it's typically heavily invaded with alien plants, or it is mowed, or it's returned to forest. There's very little healthy bushy scrub anymore. But putting this Carter right through, even though it's right through the forest, has reestablished bushy scrub, and now birds like the golden-winged warbler. If you want to find golden-winged warbler in Pennsylvania, you've got to go to one of these power line cuts. It's just about the only place that bird breeds. So you can target particular species that like a particular type of low habitat, and if you maintain it, and again, you could have groups. You could have power line maintenance groups that would keep the invasives out and keep it exactly the way a particular species want. You could have very effective Carters that go on for a long way. You know, the power grid in the U.S. with the giant overhead power lines is 330,000 kilometers long. So even if we only focused on those giant power lines, that's a lot of area that we could make functional Carters. Okay, those are the convenient options for Carters that many of us have already known about, and some people are even working on. The problem with convenient Carters is that we go to where they exist and we try to build a Carter. Unfortunately, they don't always exist where we need them. And that's a problem. Here's a great example. This is Cape May, New Jersey, Atlantic Ocean here, and this is Delaware. We've got Lewis, Delaware, Rehoboth Beach, Bethany Beach. This is where everybody goes to play at the shore in Delaware. And if you were to zoom in, you would see that it's entirely developed here. So this is a major migratory route for our eastern birds. They come down, they rest here at Higley Beach in Cape May, and then they fly across the bay, and they have no Carter at all. They have condominiums, they have hotels. Which means, so this is a perfect example of not having a Carter, a convenient Carter, where you need one. So what should we do about that? Well, this is where I would suggest we restore or attempt to restore all of our managed areas, all the places we live and all the places we work. Doesn't mean we're going to disappear. We're just going to change those landscapes so that they have some level of corridor function. You have some level of corridor function everywhere. So we have our corridors that are now no longer rigidly delineated which really makes them too skinny. We make them as fat as possible, and we restore habitats everywhere in between. So if you have a major city in here, you're going to do that less than if you have a more rural area. But the more we can put dots in these areas and fill in these blanks, the better off we're going to be. We have to stop thinking about corridors as if they're roadways, a single place to travel from here to there to there. We're really talking about restoring all of the land. What do we want to build our corridors out of? We want to build them out of plants. And the more plants we have, the more animals we're going to have. And that's because plants, of course, create the food that animals need, the food that we need too. And they do that through photosynthesis, one of the major miracles of life. Plants allow us to eat sunlight by taking the energy from the sun, combining it with carbon dioxide from the air, water from the ground, producing the oxygen that we all need. And now the energy from the sun is locked up in the simple sugars in the carbon bonds of simple sugars and carbohydrates, which happens to be the basis of all the food webs on the planet, with the minor exception of some sulfur-based food webs at the bottom of the ocean. So we've got plants making all the food, and we have plants making physical structure, providing physical structure, which is the shelter, the housing for animals. If you have plants making the food and shelter, you can look at the amount of plant life in a given space and estimate what the carrying capacity of that space is. Now, we talked about this last time, but it's probably the most important concept that we're going to offer here. Plants matter. They determine the amount of life that can be sustained in a given area. And by sustained, I mean kept there forever without degrading the resource base. This is my favorite little chart. You can plot the carrying capacity by saying we have this many plants. And again, I like to think about carrying capacity as if it were the principal in an ecological bank account. So remember, bank accounts used to generate interest, and we could live off that interest forever as long as we didn't dip into the principal. Exactly what's happening with carrying capacity. They generate ecological interest in the form of food and shelter, and animal populations can grow and cycle using that food and shelter forever as long as they don't reduce the amount of plant life. If we do reduce the amount of plant life, we're going to have less ecological interest, and any animal population using that food and shelter is going to crash down below the new carrying capacity. That's an eastern deciduous forest. Very high carrying capacity because it's making so much food and so much shelter compared to a suburban lawn, for obvious reasons. We have taken the plants out of this space. That is a plant and that's a plant, but it's a tiny fraction of the plant life that used to be there, creating just a tiny fraction of the ecological interest that used to be generated on that site, supporting just a tiny fraction of the animal life. This is not a functional corridor. If we put the plants back into this landscape, though, it's my contention that if we put enough plants back into that landscape, we really can create functional habitat. We can create functional ecosystems and functional corridors. We can start to not even be thinking about corridors anymore. The only reason we talk about corridors is because we assume we cannot fix any other area. If we fix all the areas, the need for specific corridors kind of decreases. All right, is any animal plant going to do when we're putting them back into our habitats? No, because all plants are not equal in their ability to support the food webs that we're trying to reestablish in our everywhere. And I say that because it's true. Now, I say that's what my research is about. We have been comparing plants from different parts of the world, plants that evolved someplace else. I'll call them introduced plants, with our native plants in terms of their ability to support food webs. This is autumn olive, genus Elaeagnus. The folks down south call it ugly Agnes, so we will too. Ugly Agnes was introduced as an ornamental plant about 100 years ago, has since escaped as one of our 3,400 species of introduced plants that are now invasive in this country. If ugly Agnes, and it's displacing or preventing the recolonization of a disturbed area of all of our native plants. So if ugly Agnes was the ecological equivalent of the native plants that it's displacing, then it wouldn't matter. Our ecosystems would look different, but they would function in the same way. Problem is, that's not the case. Ugly Agnes is not the ecological equivalent of the plants, the native plants it's displacing, because it's not the ecological equivalent in terms of its ability to support food webs. It does not support our insects. And I know that because that's what I have been measuring for the last many years. We're going to focus on caterpillars, and then I'll give you an update on some data. This is from a common garden experiment. Everything was controlled where the plants are planted right next to each other. A whole bunch of species of woody plants that were native versus a whole bunch of species of woody plants that were non-native. Everything, several replicated gardens in 3 different states. Everything was highly controlled. And look, we have more caterpillars, a lot more caterpillars produced by being able to be supported by the native plants than the non-native plants. Same thing with species. A lot more species of caterpillars on the native plants. This is a study we just finished this summer. These are very simple studies, yet they have powerful information in them. This is a hedgerow in a typical farm field in Maryland. And what we did was we looked at a number of hedgerows, both in June and in July, of invaded hedgerows and hedgerows that were uninvaded. We simply went down, we measured the vegetation. In this case, we've got ugly Agnes, we've got multiflora rose, we've got porcelain berry, we have Amur honeysuckle and Japanese honeysuckle. And that was the most of the invasion right here. And we measured the number of caterpillars that we found in a controlled way in those types of habitats and compared it to hedgerows that were not invaded. It's still possible to find some places where the plant life has not been invaded by non-native species. And this is what we found. 5 times more species in the uninvaded, the native habitats. 5 times more caterpillar species and 22 times more caterpillars than in the ugly Agnes invaded hedgerows. And this is why I get so excited about this. I don't know if you've heard about this, but there's a growing voice, and some of them are from scientists, like Mark Davis, a plant ecologist at Macalester College, that is saying, hey, plant invasions are not so bad. As a matter of fact, they're not bad at all. He says invaded communities are different, but they are not inappropriate. Mark and others have accused me of being too emotional. They say I don't like alien plants because I don't like foreigners. They say that. They also say the only reason I want to restore ecosystems is because I miss the way it used to be. I'm just being nostalgic. I only have one thing to say about that. I am not emotional. But I do care about the ability of this common yellowthroat to find enough food if it's in a habitat that's overrun with ugly Agnes. I can tell you, he's not going to find anything. Maybe that does make me emotional. I don't know. So when you hear those arguments, and they have been everywhere, they have been in Scientific American, they have been in repeated op-eds in the New York Times, what you never read about is what the impact of these things on food webs is. Look for that. If you don't see it, you're missing part of the story there. Why can't our native insects eat introduced plants? They can't eat introduced plants because plants don't want to be eaten. Plants want to capture the energy from the sun and use it for their own growth and reproduction. And in order to keep insects off them, they have loaded their leaves with nasty-tasting chemicals, chemical defenses, secondary metabolic compounds that are really effective at keeping these insects off. Most of the leaves out there are too bitter or downright toxic for most insects to eat. But we do know that insects can eat plants. So how do they do that? Well, they do that by specializing. There are a number of different classes of secondary metabolic defensive compounds out there, and a particular insect lineage will pick one, and you'll say, okay, I'm going to specialize on cardiac glycosides. And I'm going to develop the enzymes and the life history and the physiological mechanisms and behavior that allows me to eat plants with cardiac glycosides in them without dying. But that takes a long evolutionary exposure to the lineage of plants that makes that particular defensive compounds. It does not happen overnight. If it did happen overnight, all of our insects would be able to eat ugly Agnes. It's been here 100 years. Monarch butterfly is a perfect example. That, of course, got some crazy printing there, but it's a specialist. And It's a specialist on milkweeds. It's a specialist on cardiac glycosides. The good part of specializing is that it is able to eat a plant that is toxic to most other organisms without dying. The downside of specializing is that now that's all it can eat. If we don't include milkweeds in our carders, in our yards, we're not going to have any monarch butterflies because they cannot substitute with anything else. Same thing with the double-toothed prominent. It's a specialist on elm. And not only can it eat get around the physical or the chemical defenses of elm, but it's also, as you can see, started to look like the edge of an elm leaf. And it does that because it's part of a very sophisticated eating behavioral mechanism to avoid bird predation. Birds hunt caterpillar damage. They don't hunt caterpillars. And this guy is sitting in the area that he's just eaten, and he says there's no damage here. So the birds won't look at this leaf because there are no holes in it. And that works really well for the double-toothed prominent as long as there are elms around. But if the Dutch elm disease takes out our elms, or if alien plants, introduced plants, outcompete our elms, this guy will disappear. It's not just caterpillars that are specialists. The elderberry beetle only eats elderberry. Dogbane beetle only eats dogbane. The sumac flea beetle only eats sumac. This is a leaf-footed bug that only eats ash. So if the emerald ash borer comes and takes out all of your ash trees, you're going to lose that particular species, and that's the problem. 90% of our insect herbivores, the insects that eat plants, are specialists, just like the ones I've shown you. So again, if we landscape or build our corridors out of plants that these guys did not co-evolve with, they're going to disappear. How close are our yards to serving as effective corridors? That's a question worth asking if we're talking about restoring our neighborhood ecosystems. So we attempted to do this last summer, not this summer, but last summer. And this is Delaware, that's Maryland, and that is Pennsylvania, and I live right there. We chose 26 developments that were built by 26 different developers, and we went to these developments and chose 3 houses randomly. What we did was we start at the edge of a street corner, and we started knocking on doors. And the first person to open the door and allow us to measure everything about their landscape was the house that got chosen. Then we continued on down, and that's how we chose them. And this is what we found. We found that 92% of the area that could be landscaped in these neighborhoods was lawn. 92%. We're talking about barren landscapes. 74% of the plant species that were there, not many species, but 74% of them were there, were introduced plants. 79% of the actual plants were introduced, and 9% were highly invasive. Not because they had invaded these properties, but because the homeowner had planted them. We also compared the biomass of trees that has been left in suburbia, this area right here, with the biomass of trees that would be in a typical woodlot nearby. And in essence, we found that only 10% of the trees are in these developments. And these developments are not super old developments. We started with developments built in 1992, but they were there plenty of time to grow larger trees than existed. And we looked at the types of trees that were there. If you put a Bradford pear in, it only reaches a certain height before it falls over and is dead in an ice storm. So it's not like they're simply too young to grow their tree biomass. So essentially, we have removed 90% of the functional, the meat of a corridor situation from our suburban yards. 90% of the food is gone, and that's why when we look out the windows, we typically don't see anything. If I took away 90% of your food, you probably would go elsewhere until you found something to eat. So that's where we're starting from. I would like to encourage us, as we're thinking about corridors, but just in conservation in general, to start thinking about conservation at home in terms of producing the ecosystem services that we humans need. We need clean water, we need carbon sequestration, we need conservation of biodiversity to run our ecosystems. If you have 92% of your yard as lawn, you are not making clean water. Don't depend on the Smokies to make your clean water or the Rocky Mountains. You've got to do it right home now because there's not enough natural areas left to do a good job of that. Why aren't you making clean water with your lawn? Because lawn makes dirty water. When it rains, most of it runs off, so you're not holding it on site, you're not recharging your water table. If you use fertilizer and herbicides, or if you hire a lawn care company, you know, a lot of people will buy turf builder and think they're buying fertilizer, but there is an herbicide in there as well. Then, of course, you're putting nasty things in that water, and when it runs off, it carries it all down to the nearest stream. If you want to sequester carbon, you need more than 10% of the trees that could do that on your yard, and you need to choose trees that are long-lived. You don't want to sequester carbon with fast-lived trees because they don't live very long. Pick something that grows slowly. These are Bradford pears in bloom, beautiful, but the next ice storm that comes along and they've split in half, and you start over. So you have no net carbon sequestration here. And then, of course, if you want to preserve biodiversity, you've got to put the plants that are going to support the food webs of all of the creatures that you're trying to save. If you put black cherry into your suburban corridors there, you will attract the white furcula. You can have the tufted bird-dropping moth. You can have the twin-spotted, or this is the small-eyed sphinx, I guess, the red-spotted purple that is looking like bird dung. If you want the walnut caterpillar, or if you want the gray-edged bomaloca, you need to have black, or if you want the black-blotched caesura, then you need to have walnut. If you want the rosy maple moth, or the retarded dagger moth, or the Plagodes inchworms, then you need to have native maples. If you want plume moths or forester moths, you need native grapes. If you want the four-horned sphinx, you need native elms. If you want deer, never mind. If you want the horrid zale, or the hummingbird moth, or the rosy hooktip moth, the only thing they eat is viburnum. That's got to be part of your restoration. If you want the common gluphisia, then you need poplar. The brown-hooded owlet is only going to be found on goldenrod, and of course our friends the milkweed insects, our monarchs and our large milkweed bug and our milkweed caterpillar and our milkweed beetle all require milkweeds. These are obvious things, but if they're not in our carters, we're not going to have these things. If you want the spicebush caterpillar, then you have an option of either sassafras or spicebush. The hog sphinx, the Pandora sphinx, the abbot sphinx all require Virginia creeper. Astrocampa, the hackberry butterfly, or the this is doing this without me. The question mark. Okay, we get to hackberry. Then you got to have hackberry. So you know, are we done? No, of course not, because there's a lot of insects out there. If we want to have the sycamore tussock moth or the drab prominent, we need the sycamore. The luna moth and the large pectes, of course, need the sweet gum trees. Juniper hair streaks need juniper. The turbulent philosopher needs smilax. This is the morning cloak, hourglass furcula, and the viceroy need willows. So you're getting the idea, I think, here. This is the linden looper. It needs linden. This is the variable oak leaf caterpillar, the southern oak daggerworm, the red-lined panapoda, the laugher. Certainly we need the laugher in our corridors. This is the oblique heterocampa. Then we need oaks, a mainstay. And if we want the tulip tree moth, then we need tulip trees. If we want the zebra swallowtail, of course, we need pawpaw. You certainly get the message. Remember, 90% of the insects that we want out there, or that exist out there, are specialists. You might say, why do we want all these insects? We're building corridors to save biodiversity. Most of our biodiversity is in the form of insects, but if you don't like the insects that we're saving, they are the food of what everything else eats. So we want these insects in our corridors because that's what things eat. All spiders eat insects, other insects eat insects, frogs eat insects, toads eat insects, all of our amphibians eat insects. We're talking about most of life here. Our lizards eat insects, our bats eat insects, our rodents eat many, many insects, not just seeds. Larger organisms eat insects. The skunk is digging up your yard to get the grubs that are in your yard. Insects are excellent food. Pound for pound, there's twice as much protein in insect meat as there is in beef. And insects also have organs in their abdomen called fat bodies. They're extremely rich in energy and allows these guys to grow really quickly. Things we don't think of as insectivores eat a lot of insects, like my friend the fox here. This is what I see when I look out my front yard. Anyway, brown bears. Black bears, 23% of a black bear's diet is insects. So even the large guys are depending on insects. Even things that don't eat insects directly depend on insects. This is a sharp-shinned hawk. It's not eating insects directly. It's eating birds. But the birds that it's eating needed insects to become birds. So it's indirectly tied to the health of its insect community. Same with most of our snakes. They're not eating insects directly, but they're eating the frogs and the toads and the rats and the things that ate insects. And of course, our baby birds need those insects. 96% of our terrestrial birds eat insects, rear their young on insects, or the book will say other arthropods. And the other arthropods are the spiders that needed the insects to become spiders. 96% of our birds. If we take insects out of our biological corridors, the brown thresher is not going to be able to rear its offspring through to maturity. Which is why that hedgerow that the farmer thinks is doing a great thing for his fields is producing absolutely nothing for these birds. And of course, this is the type of habitat that's not going to support that brown thrasher for obvious reasons. How are we going to get the plants into landscapes like this? We're going to flip-flop the landscaping paradigm that we've followed for the last century. What we have done is build our house, and we've carved out little areas that we call flower beds, and we planted a tree here, there, and there, and then we're always tired. So just by default, everything else becomes grass. Let's flip-flop that. Let's build our house, and then we want to carve out the area that's going to be grass. Where are we going to put our grass? I am not saying no lawn. Grass is a really functional plant that allows us to walk on it without dying. So any place you're going to consistently walk around your property is a good place for lawn. If you want to get married out here in the front yard, you should have lawn. If you want to move to the backyard, nice grass path, throw the frisbee back here. Wherever you want grass, good, go for it. But when you are finished, everything else becomes heavily planted. And this becomes the landscaping design challenge of our times, because how can we get this much plant material back into our landscapes without them looking wild or messy? Most people don't like wild or messy. I know wild ones like the word wild, but we've got to fit these landscapes into traditional suburban neighborhoods without being thrown out on our ear. We can do that, but it's really a design challenge. I am not a designer, but I'm talking to designers who are working on these problems. And I've seen a number of landscapes that are really well done. This area can be a functional corridor. Now, if we do this in half the area that we now have in lawn, let's say we've got 40 million acres, it's really 45.6, but let's say we have 40 million acres in lawn, and we put biological corridors in half of that area, we can make a new national park, and it will be 20 million acres in size. Let's call it Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, plus Canyonlands, Mount Rainier, North Cascades, Badlands, Olympic National Park, Sequoia National Park, the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. You add up all of those parks, and it's still less than 20 million acres. So our homegrown national park is going to be huge. There are two things we need to do when we're going to build an effective corridor. We need to put more plants in than we have right now. That's why they're not effective corridors. They don't have the plants. And those plants, if we want them to be super effective, they all have to be native. If we insist on a favorite plant here and there that gives us a particular aesthetic or is part of our natural heritage. My dean is from North Carolina. And she said, well, at least crepe myrtle is native. I said, no, it's not native. She said, it's not, but it's part of my heritage. And I said, are you from China? She's not from China. She's from North Carolina, which happens to be, that's the only plant they plant in North Carolina is crepe myrtle. But she insists on having some crepe myrtle in her yard up here in Delaware, and that's fine as long as it's not the only plant that she has. We want to put grass where we want to walk. And It's really, if you think about where you have walked on your property, and I'm not talking about where you walk in order to mow it, in the last year, it's really not very many places. Could you deal with a backyard that looks like this? Even though you only have grass there, I could. It would work for me. Now, here's a homeowner that decided she never walks over here, took all the lawn out, and made a nice meadow out of that. It becomes a functional corridor. There are obvious areas where we want to take lawn out and do something else. So here again, we have meadow. Here's it slopes off. You don't want to be mowing where it's slopey. We want flat areas for our grass. Mowing slope is a dangerous thing. We also can transition from established woodlands or areas that are a little bit more densely planted down to our traditional lawn with very wide flower beds. Every time you widen your flower bed, you have reduced the amount of lawn that's in there. This is bottle-brush buckeye, really good plant, particularly around here where it belongs. And it's really attractive to butterflies. There are 5 swallowtails on this single bloom in this single picture. Another obvious place to get more plants into the landscape is around some of the artificial waterways that we've put in. A lot of people have ponds in their yard. And this is one of my neighbors has this particular pond. I've always thought that it's a temporary, that they're working on it. But it's been 5 years. They are not going to put any vegetation along there. And what a missed opportunity. They could have it lined with Joe Pineweed and other species of eupatorium, with willows, with alders, with buttonbush, with clethra, with things that that like their feet wet, but really productive plants. And I think they're a whole lot prettier too. Now this is a planned planting. I mean, this is a lake at a park. And they had these clumps of plants. And I looked at the plants that are in there. There were 9 species of woody plants in that planting. All of them were appropriate, but they were obviously planted very, very densely. And they had these clumps as they moved along the shore. So you could still get to the lake, but they obviously put in a lot of vegetation that is holding the shoreline and being a patchy but still effective corridor. Another interesting way we could get more plants into the landscape is to put them in our flower beds. That's 90% mulch. Forget that that's, what is that, burning bush, we introduce plants. Let's put the right plants in there, but let's not start, we're not making mulch beds. We've got to get used to planting plants densely. If you can see the ground, even though the plants are going to grow, you are losing a planting opportunity. This is what the view from our dining room window looks like. That's Viburnum dentatum when it's blooming. I can't see the ground. That's okay, I don't have to weed it then. Don't shy away from planting large trees. I mean, you plant them when they're small, but they grow. So many times I hear landscapers tell people, do not plant an oak because it grows so slowly you won't live long enough to enjoy it. But I'm going to challenge that with a series of shots. This is a white oak that I put in my front yard with an acorn. It's 6 years old in this picture. And she's 2, 7 years old, 8 years old, 9 years old, 10 years old, 11 years old. She's 7 now. She's very tall for her age, but look, the white oak is beating her in this race. It's true, that is not a 300-year-old oak, but I am enjoying it, and she is too. She looks forward to this. Every year we're going to go take our picture next to the oak. I'm going to do it forever. But even when that tree was little, it was being productive. This is Polyphemus moth I took on that particular tree when it was 7 years old. It now has an established population of Polyphemus that are there every single year. This was I guess it was a field sparrow nest that was in the tree when it was very small. So these trees are functioning, even though they're growing. Cost, particularly these days, is something you have to think about. The acorns are falling right now. They are free. Go out and get them. Don't just plant them out in the ground. The white oaks germinate now, so you have to put them where you want them. But I would start them in pots. Every time I plant them straight away, the rodents get them over the winter, and they're not there. So I put them in pots, and then when they come up in the spring, then I plant them out. Where I live, if there's not a cage around it, then you don't have it. The deer have gotten it. But anyway, you make that investment, and it doesn't cost anything. You know what that is? It is a seed. It's a seed of the American elm. That's what it looked like 2 weeks later. That's what it looked like 9 years later. There I am. And even though I'm very, very tall, you can see that that elm has grown a lot in 9 years. This is the American elm. You also hear that. Don't plant an American elm. It's going to get Dutch elm disease, and it will die. Maybe it will someday. But in the meantime, I've gotten 9 years of productivity out of that tree so far. No signs of dying at this point. I collected those seeds from trees at the University of Delaware that have not died. Maybe there's some resistance in there. It's probably not going to live forever. But you also don't have to do American elm. You have slippery elm around here that's much more resistant to the disease. Elm is a really good tree to get into your landscape. And it grows quickly. A great tree to think about for your corridors. Let's think about minimized specimen plantings. That's a specimen plant. I mean, that's supposed to, I don't know what that is supposed to do. I guess it's artwork or whatever, but that's what when we put trees in, we want them to reach their maximum aesthetic value, so we clear everything away. This is an intentional planting at Mount Cuba, Delaware. So we have hemlocks put in with oaks. It's a plant community. So rather than a single specimen plant that's not functioning in terms of anything we want in a corridor, now we have a plant community that's beautiful, and it's simply a collection of plants that are working together. Here's a plant community that is natural. These are tulip trees, and that's a Cornus florida that this homeowner did not chop down when they put the house in. So they've maintained part of this understory community that is beautiful. It works together. And it gets more plants into the landscape. You've got an understory bit of biomass here, so you don't just have canopy with nothing right down to the ground. We also need to develop rational tolerance of other species in our lives, in our landscapes, in order to achieve sustainable landscapes. Now, this is a shingle oak at my house. How does that look? If you looked at that oak, would you run for the spray can? It looks okay to me, but on closer inspection, this branch had its leaves stripped, and so had that branch. You couldn't see that when you're standing back a little bit. It had it stripped by the contracted Daytana, which happens to be a gregarious notodonted moth. I think it's beautiful. I look forward to them every year, but because they feed together, they take all the leaves on the branch they are on. If you have just one little tree with one little branch, yeah, it'll defoliate it. But in a tree the size of what I just showed you, you don't even notice it. But this is what people do worry about. Are natives that we're building our corridors out of, that we're putting into our yards, going to suffer more insect damage than crepe myrtle and other things that we used to put into our yards? And the answer is no, not if we build balanced ecological communities. Because we have a lot of natural enemies, like this yellow-bellied sapsucker here, eating those insects. How do I know that? Well, I can say that now for sure because we have data to support that. We have compared the damage on native ornamental plants and properties that are planted largely, not entirely with natives, but largely with natives for sucking insect damage and chewing insect damage compared to traditional landscapes that do have some native plants, typically the canopy trees, but most of the understory trees are non-native. And after 2 years of data, we actually had significantly less damage on the native properties. Even if they were equal, I would be happy because people worry there's going to be so much more damage on your native trees because all of these insects are going to come eat them. The evidence doesn't bear that out if you have that balance in your yard. This is the aesthetic injury level up here. Other studies have shown that homeowners don't even notice insect damage till about 10%. About 10% of the leaves are damaged, which means so this is very little damage overall. The homeowners that these data were taken from would probably say, we didn't have any insects at all. They wouldn't have noticed this damage at all. So both of these types of landscaping are well below what a homeowner would respond to, which means this is going to work aesthetically in terms of insect damage. What I like about this approach to conservation is that there are no political overtones to it, or it's not constrained by some of the ideologies that have really killed some good ideas in recent years. So really, no matter what your politics are, no matter what your religion is, we can all agree that everybody needs functional ecosystems. So that means all of us can do this. We all can enjoy this. I saw this sign the other day. Do you have this billboard out here? It's a picture of Jane Goodall with a chimp. It says, even Mother Nature has an agent. And Jane has been a wonderful agent. But I want to stress that Jane needs help. And don't think you've got to give up life as you know it and move to Africa in order to be Mother Nature's agent. Mother Nature needs an agent right here. Jane is helping chimps and everything associated with that ecosystem, but you can help hundreds or thousands of species right at your places of work and where you live if you follow these suggestions. Alan Hershkowitz last year said that a lot of people think that conservation means you have to diminish your lifestyle. A lot of people think that, but I couldn't disagree more with that. There's no way we can put these plants into our lives, into our, where we live and work and farm, and have our lives diminished, because when people interact with nature, they enjoy it. It's an enriching phenomenon. So if you do this, I really am going to argue your life is going to be enriched, and I wish you luck. Thank you very much.